From net you have uploaded or from textbook? Sorry,
From
text.
textbook only.
Okay, I'll check. I'll finish this work.
Yes,
because
ma'am.
most of you are confused with this. This is the first time CBSE is changing all those things. Okay, fine. So vector product will not be there in motion in a plane. Is that correct? Is that clear, boys? I'm going one by one so that you will not find it tough. Motion in a plane, case of uniform velocity and uniformly accelerated projectile motion. This is all about projectile motion, motion in a plane, where you have uniformly accelerated motion. The projectile. Are you clear? 11B?
Yes, ma'am.
Okay. The last statement is for projectile motion, and you have uniformly accelerated circular motion. Page number 4. Sorry, it is page number 79, 4.11. Uniform
So
motion.
that covers centripetal force, right?
Yes, that is centripetal force. Uniformly accelerated projectile motion. Uniform circular motion is it is 4.11. Uniform circular motion. Is that you need? Yes, 1 second, boys. Is that you need? I have to write 4.10, 4.11. That would be better for you all. Is what CBSE is stating is tough for you to check?
No,
Should I?
No,
If you want.
Subtopics, right? We can.
Or else 1 second, boys. Or else here itself I'll make it clear. So motion in a plane. Just if you have your textbook, bring your textbook, boys. We'll mark that over here. Bring your textbook. You have your textbook with you, or can you write? Just keep writing. If you have a textbook, you put a tick mark because so much of confusion is created. Okay. Motion in a plane. Motion in a plane. 4.1. 4.2. 4.2.1. 4.2.2. 4.3. 4.4. 4.5. 4.6. 4.7. 4.8. So relative velocity in 2 dimensions at numerical, boys. That's what here they specify. 4.9, 4.10, 4.11. So almost it covers. If you want to just go for deleted one, nothing is deleted in motion in a plane. So you need not worry about it. Okay, fine. Here,
laws of motion and motion
laws of
statements
motion. Yes,
work
boys.
in
Laws of
convergence.
motion. Yes, boys. Laws of motion. See, look at this. It's only the intuitive concept of force, but in revised. So this is already what you have learned in your grade 9. That's what they have specified. We are only going through it, but since we have completed, so where I'll tell you where we have to start from. Laws of motion. Impulse is also not there, right? Impulse is also not included. So we'll start with. Can
Ma'am, in
you?
the cutoff, it's starting from law of conservation of linear momentum. Like they're taking the first full that 2 lines in
Yeah.
motion.
So you need not learn, boys. You need not learn because before this was being sent to us by CBSE, we have already completed. So in your textbook, laws of motion, I'm just reading out 5.7. Okay. 5.7, conservation of momentum is over there. Then you have 5.8. a law of conservation of a linear momentum and its application is a recoil of a gun. Okay. Then 5.8. Then 5.9, 5.91. 5.91. Then you have 5.10, 5.11, everything. Till there. Clear? Boys, all these things are clear right now for you. So what for laws of motion, your chapter starts from 5.7. The one before 5.7 is not there. Okay. Is that fine, boys?
Okay, ma'am.
Yes, ma'am.
So where you are finding it difficult, only motion in a straight line, correct? Motion in a straight line. Here is
Ma'am,
that.
so other than all, like the thing that they have cut off is not coming, only motion in straight line is the problem.
Motion in a straight line, that's what I'm telling you, because the deleted portion slightly varies with this. So whatever is over here as shown by your revised physics syllabus, you go for it. Is that clear, boys? So vector product is not there. Huh?
And the topics which you said in laws of motions are coming, right?
Laws of motion, one second.
From 5.6.
5.7, 7, conservation of momentum.
Okay, ma'am.
From 5.7 till the end of the chapter.
Ma'am, what about work energy power?
Okay, work energy power only, where is it? We stopped only till with work energy theorem. Have you checked? This is the entire syllabus. What we have put is work done by a constant force and a variable force, kinetic energy, work energy theorem. Only till that, till work energy theorem. Is that clear, boys?
Work energy theorem for variable force, right?
Variable force, both constant and variable force. If you want, I'll just state you that 6.1.1 work energy theorem, 6.2, 6.3, 6.4, 6.5, 6.6. That's it. Till 6.6 of your work energy and power. Is that fine, boys?
Ma'am, so conservation of mechanical energy, potential energy.
No.
Okay, ma'am.
Ma'am, for the log table, are we allowed to keep a sheet of paper or the practical textbook beside us?
Yeah. You need to do have it, boys.
Okay, ma'am.
Let me try, boys. If you people are still getting it confused with your revised syllabus, what is CBSE is putting? Let me see. I will put all the subdivisions and then I'll send you. I feel. Which one?
We got a question.
What happened?
No, Taisa, you go first. Taisa, you go first.
No, nothing. I was just saying that I understood. We understood like what ma'am was saying. Harish, you can continue.
Yeah.
No, boys. I think so. I have discussed. If you still have any difficulty, I will type all the subdivisions and we will put. Okay. Because what has happened is yes, boys. What happened is that before the revised syllabus of CBSE came, we have already completed most of the topics in the chapter. That's what you people are getting it confused. So is it fine for you now?
Yes, ma'am, we understood.
I
Also, ma'am, for work energy and power, what kind of questions will they ask? Like numerical wise.
Okay, fine. You don't have reference books with you, boys? Do you have reference books?
No, ma'am, it's very difficult to find one for grade 11.
It's a reference book.
Ma'am,
No, not
I
from
study from Vedantu, ma'am. Like they're online, they do classes and all.
Okay, one second. So questions are becoming a problem for you all. Work energy theorem. I haven't given the questions over there, boys, for work energy theorem.
Ma'am, we did like 2 questions like a bullet weighing 10 gram is fired with a velocity of 800 meter per second.
One second. I think so. You people, boys, if I can take a picture and send it to your group ID, will you be able to see what are the types of questions? Will the clarity be good?
Yes, ma'am. Yeah, will be fine.
Yes, ma'am.
Clarity
ma'am.
would be.
Yes,
So
ma'am.
then in that case, I have to take a consent. I will do that for very almost all chapters you need. Let me do that and send you. Fine, boys. PowerPoint presentation. You can see the PowerPoint presentation.
No, ma'am.
Big screen, screen.
Okay. What?
Succeed, Mike.
I said Mike, yeah.
In that case, last period, I'll start with your division bus motion in a plane. I'll start with that. Can you start writing this question? This is for perfectly elastic collision. 10 kilogram and a 20 kilogram ball approach each other with velocity 20 meters per second and 10 meters per second. What is their velocities after collision if the collision is perfectly elastic? Did we do this numerical? 1 second, boys. I'm just, because I've done this in the other class. Did we do this numerical? The bob of a pendulum is released from a horizontal position A as shown. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at the lowermost point B? Given that it dissipates 5% of its initial energy against air resistance?
No, ma'am, we didn't do this.
And we like drew the diagram.
You have the, okay, fine. Boss, you have simple pendulum. Now it is at an extreme position A. A is the extreme position. And B is the rest position, right? So now in a simple pendulum, when the pendulum is at the extreme position, the energy will be purely potential. When it comes to the mean position, the energy will be kinetic. At the extreme position, the energy is purely potential. When it comes to the mean position, it is purely kinetic. Only from extreme to mean position. So from mean position to another extreme position, as the pendulum is oscillating, potential will be converted into kinetic, kinetic will be converted into potential. Right? So now here, initially, as per the numerical, the pendulum is at the extreme position A. So here its energy is totally potential, mgh. So when it comes to the position B, its energy is totally kinetic, half mv squared. Now, when it reaches this position, the question is, what is the velocity of the pendulum or the metallic sphere at point B? And look at this. It dissipates 5% of its initial energy against air resistance. Say from point A, when it comes to point B, 5% of energy is lost, which means when it comes to point A to point B, the energy of the simple pendulum at point B will be 95% of its energy at point A. So I can write energy at point B is equal to 95% of energy at 95% of energy at point A. Fine, boys. So what is the energy at point P? It is half mv squared. What is the energy at point A? It is 95%, 95 by 100 of energy
MGH.
at point MGH. So can you find what is the value of V? Find the value of V, boys. Just check what is the value of V. What is the value? You can take GS10 and just check what is the value.
Now I'm getting root of 28.5.
Yeah. So just take the square root. Others have you completed, boys? Others?
Yes, ma'am.
So boys, M and M will get cancelled. M and M will get cancelled. Then in that case, you have to find V squared. H is 1.5 meters. H will be 1.5 meters. To find the value of V. Can you do this numerical, boys? It's perfectly elastic collision. You have an object of mass, say M1 is moving, M1 is 10 kilogram. It is moving with a velocity U1, which is equal to 20 meter per second. Approach another body of mass 20 kilogram. So M2 is 20 kilogram. Moves with a speed of.
Ma'am,
Yes.
for the previous question, what were we supposed to take? G
Find
as?
the G. Right now you take it as 10.
Okay.
Now you know what is the formula for final velocity V1? It's a
Ma'am, what
perfectly
was
elastic
the
motion.
final answer for the previous one?
It was root 22 point something, right? Just check the square root. What others? What is the value you people are getting, boys? For the
Ma'am,
previous
I'm
Root of
getting 28.5. Root 28.5.
I'm
Yes,
root
yes.
of 28.5.
It will be somewhere between 5 and 6. Fine. V1 is equal to M1 minus M2. Boys, because I haven't done numerical on collision, into U1 plus 2M to U2 divided by M1 plus M2. So, and for the V2, you have to change the subscript. So you find what is the value of V1 and find what is the value of V2. It's a direct substitution numerical. So what will be the value of V1, boys? V1 is equal to One second. Look at the statement. Both the bodies are approaching each other. So U2 should be positive or negative? Both are approaching negative. Because both are approaching each other. If one is taken as positive, the other one should be negative. So U2 becomes minus 10. So M1 is 10 minus 20 divided by 30 into U1 is 20. Then plus 2 into M2 is 20. U2 is minus 10 divided by 30. Just check what is the value, boys. What is V1? So two bodies are approaching each other, which means they are moving in opposite direction. Find the value of. So this will be minus 10 into 20.
Is it minus 20 meters per second?
Okay. Someone getting a different value? Anyone, boys? So what's the answer, boys? What is V1? What is the value of V1? You haven't calculated 11B?
Ma'am, I got to minus 20 meters per second.
Minus 20?
Meters per second.
Okay. Minus 20.
Is it correct?
Others, just check, is it correct?
Yes, ma'am, even
Minus
I got minus 20.
Minus 20. Okay. But negative sign, did you take into consideration the negative sign?
Yes, ma'am. Direction, right?
Here?
Yes, ma'am. I took the U2 as negative.
Even others are getting the same value?
Yes, ma'am.
Minus 20.
Yes, ma'am.
Which means in which direction your M1 will move?
Ma'am, the opposite direction.
Okay.
Like
What
after
about after collision? Then what will
before
be the?
collision is going right, after collision go left.
Okay, fine. What about V2?
Negative will be, if the
Opposite.
answer is negative, it is opposite of what you assumed, right?
Yeah, what you have assumed. In U1, you have assumed it's moving positive x-axis, boys. Positive x-axis, you are taking it as positive. All what is moving along positive x.
Ma'am, basically that's I cap, right?
Yeah. Negative x-axis will take it as negative. So now V1 is negative, which means it's moving towards your left. What is moving towards your right? All the physical quantities towards your right, you take it as positive. Same way, you have to calculate V2 also.
What's V2?
V2 answer is it positive 10?
Ma'am, our maths period started.
Ma'am, our maths period started.
Okay.
Ma'am,
sorry, ma'am.
Thank you,
V1.
ma'am. Ma'am, fifth period you will do revision?
No, fifth period I'll start doing revision.
Okay.
What's
Thank you,
V1 answer again?
Ma'am.
Oh, yes.
You can like ask the other physics teachers and get back with us with the motion in a straight line.
Motion in a straight line, only this much. We have already discussed, boys. We have already discussed. So everything is discussed, right? Only the relative velocity is not there in the first chapter, but the numericals related to relative velocity in this is there. Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.